we're here to talk about the Chapel project, which is one of the programming languages. Before we talk about the life cycle of the project, can you just briefly describe Chapel, what the project is, and what it brings to the ecosystem today?
The motivation for Chapel and for ZPL, the language I worked on in grad school before it, was that programming, well, I should say, doing parallel programming at all is hard. And for those who don't know what parallel programming or parallel computing is, it's basically the notion of using multiple processors or multiple computers cooperatively to solve a problem faster than you could otherwise. And so a simple analogy would be, if I have some problem that's going to take me 100 hours to solve, well, gosh, if I had 99 friends help me with it, maybe we could solve it in 1 hour because we could split up the work. Now, the complication, of course, is that just like if you had 99 friends helping you, you'd have to do a certain amount of coordination between those friends to make sure everyone was doing unique work and the results were coming together in the right way and people weren't stepping on each other's toes. The same thing is true in parallel computing. And so it sort of has all of the challenges you would have in traditional desktop sequential or serial computing. But on top of that, there's the problems of coordinating all of these parallel workers. If you're using large-scale systems like supercomputers or the cloud, you may have data in different memories and you need to somehow get the data back and forth between the memories. So there's sort of a lot of details to deal with. And the theme of both Chapel and ZPL before it were to be languages where those details were handled much more automatically for you by the language, by the compiler, by the runtime, and less sort of you having to deal with everything yourself manually. And so at a really high level, you could think of the goal of Chapel as being to have a language that is sort of as approachable and easy to read or write as something like Python might be. Not to say Python's the perfect language or anything, but it's obviously very popular, and I think it's sort of readability and writability is a big part of that. But where Python is a language that hasn't really generally resulted in great performance or parallelism or scalability, which is the notion of running on these very large-scale systems. Our goal is to get the same kind of performance and scalability that HPC programmers would expect from the conventional technologies that they use to program them today. And so the big difference between the two is in the conventional technologies, often you're being very explicit about, now I want to copy this data from my memory over to your memory. Now I want to have you start working on this. And all of that's very explicit. And in a language like Chapel, a lot of that is abstracted away by the language or by abstractions in the libraries to prevent you from having to deal with it in quite such an explicit manner all of the time.